Okay, so recording is already started, so we will start the session for today. So yesterday we have discussed about the how we can calculate the mean and the median for the grouped discrete data. So now we today we are able to calculate the how we can calculate the mean for continuous group data. So as this we continue with the last class. So this is the data. So this is the continuous data with the both the conditions will meet like 50 class interval, and the classes are all of equal size and plus the inclusive in nature 1100, 1100, 1150, 1150 and so on. So both the conditions will get satisfied in this, so then we can proceed with the further solution. Now in this particular case, again the same process, the 207. So 207, the half of 207. So 207, if we'll do the half, that becomes, so if we'll make half of this, it becomes 103.5. So we have to check that where 1.103.5 lies. So 103.5 lies in, if we check this cumulative frequency, 103.5 lies here. So 103 is up to this. So 103.5 lies in 177, this class. So that means 1150 to 1200, that will be my median class. But we don't get the median yet. We'll get the median class, but not the median. We cannot say that the median is 1150 to 1200. So it cannot be 50 numbers, cannot be a median. So median has to be a single number. So next process is we want to find, we have found the median class, but we want to find the median of this from this. What is the median from 1150 to 1200? So next task is to calculate the median from 1150 to 1200. Fine. So for that reason, what we have to do, either we have two things. One, we have interpolation, and interpolation is a method, and the another is like a formula. So we'll use the formula only. Interpolation is the method which derives that formula, but we will don't will go with that details of the interpolation method. We'll simply go with the formula for the calculation of median of the continuous grouped data. So the median is equal to 1 second. Hello, audible?
Yes, yes.
Yeah, so median is equal to, okay, okay. So median is equal to
Yes, sir.
L, L plus, write down the formula first and then we will discuss. L plus n by 2 minus CF divided by F and whole multiply by I. So this is the formula for the median, which is L plus n by 2 minus CF divided by F into I, where L is the lower class limit of the median class. So we have already found the median class. So we have already found the median class, that is 1150 to 12. So L is the lower limit of that median class. So no cross talk, students. You are being recorded. So L is the lower limit of the class. So lower limit of the class is 1150. So L is the lower limit of the class. So which is the median class. We've already found that 103.5 lies in this 1150 to 1200 class. So this is your median class. So L is equal to 1150. So L is equal to 1150 n by 2. N by 2 is n is 207. So n by 2 is 103.5. Now CF is the cumulative frequency of the class above this. So cumulative frequency is the cumulative frequency of the class above this median class. So here is the cumulative frequency. So the cumulative frequency of the above class. So that is 103. So cumulative frequency becomes 103. That is for the class above the median class. So CF value becomes 103. Then F is the frequency of that class itself. So F is your 70. Sorry. So F value is your the frequency of the same class, which is 74, and then I is the class interval, which is 50. So everything is known to you. You apply this formula, you'll get the answer. So median is equal to L is your 1150, lower middle class. So lower medium जो class है, lower limit, that is your 1150 plus of n by 2 is your this value, n by 2 103.5 minus your CF is the median class frequency of the above, that is 103 divided by frequency of the same class, which is 74, and whole multiply by the whole multiply by I is your class interval, which is 50 here. So that comes out to be 1150.337838. So that comes out to be the median of continuous grouped data. So remember this n by 2 minus CF by F into Y, L is after this. It is not whole divided by, it is n by 2 minus CF by F. And L plus is outside that division part. So that becomes the formula for the median. So in this way, you can calculate your median for, so here it is not need, whether it is a even, whether it is an odd, you have to simply use n by 2. So if it is odd, it comes out to be 103.5. If it is suppose 208, it comes out to be 104. It does not mean any difference. So in the continuous, whether it is number of terms are odd, whether the number of terms are even, we are not like bothered about that thing. So that way in we can calculate the median of grouped continuous data. Now in the family of this median only, we have the another tools. We have like quartiles, we have deciles in the same family of median, and we have percentiles. So we have three like further tools available in the family of the median, that is quartiles, deciles, and percentiles. So these are like quartile, deciles, percentiles. Our median is, the definition of median is that which divides the data set into two equal parts. Quartile, the quartile itself says quarter. So quarter says the quartile is the value which divides the complete data set into four equal quarters. So quarter से quartile है. So four equal parts. So here we have three measures of the quartile, rather two only, Q1, Q1 and Q3. It can be Q1, Q2, Q3. Q1 says 25% is below it and 75% is above it. Q2 is 50% below and 50% above, which is none other than median. So if we are calculating Q2, we are calculating median. So that's why we are not defining Q2 as such, because Q2 is none other than your median only. So we have our values like Q1 and Q3 in quartiles. So Q1 says 25% below, 75% above, and Q3 says 75% below and 25% above. Decile says 10 equal parts. So we are dividing the data set into 10 equal parts, which will be like, if it will be from D1, D1, D2 to D9. So these are the 10 equal parts we are dividing. So again, D5 is 50-50. So D1 means 10% below, 90% above. D2 is 20 below, 80 above. D5 means 50-50. So we are not calculating D5, we are calculating median in that case. And D9 says 90% below and 10% above. So that's why the median is, deciles is like D1 to D9, and 10 equal parts. Deciles. Deciles stands for 10. So 10 equal parts is D1 to D9. And then percentiles will be like 100 equal parts. So it will be P1, P2, and so on up to P99. So these will be the 100 equal parts, in which we have P1 is 1% below and 99 above, 2 is 2% below, 98 above. So in that case, we have a percentile which divides the complete data set into 100 equal parts. One second. Hello. So P1 से लेके P99, so that becomes your 100 equal parts of the percentiles. So now we want to calculate this quartiles, deciles, and percentiles of each class, like of each class interval or so. So for that, again the same principle we have to apply here. Suppose we want to calculate Q1. Let's suppose we want to calculate Q1. Q1 is four equal parts and Q1. So we have to have the four equal parts. So if we'll decide this four equal parts, so first is again the sigma F is 207. So again the comes in the median we have done n by 2. In quartile we'll calculate n by 4. So in the quartile, we'll calculate n by 4. So n by 4, if we calculate, quartile is 4 equal parts, so that's why n by 4. And Q1 is n by 4. If we want to calculate Q3, it becomes 3n by 4. So that is the difference in Q1 and Q3. Q1 says for n by 4 and Q3 stands for 3n by 4. So first, because we want to calculate Q1, so we'll first calculate n by 4. So 207 divided by 4. So if we'll calculate this, and is this 207 divided by 4, it becomes 51.75. Fine. So 51.75 is your n by 4 value. So now if we want to check this n by 4, what is this n by 4? So 51.75. So it lies in this class only. So we have found that first quartile lies in the 1050 to 1100. So from this 51.75, we will come to know that it lies in 52 only. So that becomes 10502 1100. So the median class will lie in this. So 1050 to 1100. So this we have found the crotile class. So 1050 to 1100. The same principle as we have applied here for median, the same we can apply for Q1. The change only is that is it will change this. I'll copy this only. So the formula for crotile 1, the formula for crotile 1 becomes L plus, here it is n by 2, now it becomes n by 4. The only difference comes is like in case of median it is n by 2, in case of crotile it is n by 4, and L is the lower limit of the crotile class we have found. So crotile class we have found that is 1050, so L value is 1050 plus n by 4. What is the value of n by 4? 51.75 minus CF. CF is the cumulative frequency of the above class. So it is the first class only, so cumulative becomes 0. So that is 0 divided by the frequency of the same class, which is 52. So divided by 52 and multiply by class size, which is 50. So if you will do this, so 1099. So 1099.759, that becomes the first crotile Q1. So that means 1099.75 will divide the from 1099.75, 25% values are below it and 75% values are above it. And let's suppose now we want to calculate Q3. So what is the difference in Q3 now? So Q3 we want to calculate. So Q3 becomes 3n by 4. So Q3 becomes 3n by 4 because Q3 stands for like 3n by 4. So n by 4 stands for Q, as because it is Q3, so it becomes 3n by 4. So now we calculate 3n by 4, which will be equal to 3 multiply by 207, 3 into 207 divided by 4, so that is 155.25. Now we have to check where this 155.25 lies. So 155.25 we will see lie in this class. So 1150 to 1200 is the Q3 class. So 1150 to 1200, so it will apply the formula for this, so it becomes L plus, so L is 1150 plus of then n by 3n by 4. So 3n by 4 value is, we've already calculated 3n by 4 is 155.25 minus of cumulative frequency above it, which is 103, divided by this frequency of the same class, which is 74, and multiply by I, which is 50. So 1185.3, that is the value which has 75% below it and 25% above it. So in that way you can calculate your like quartile, any quartile Q1, Q3, if it is decile. Suppose now next question is you want to calculate D6. Let's suppose we want to calculate D6 or D8 maybe. So if we'll calculate D8, so D stands for n by 10. 10 equal parts, so that why D stands for n by 10. And as we have to calculate D8, so it becomes 8 n by 10. So D stands for n by 10 and D8 is 8 n by 10. So if we want to calculate 8 n by 10, so 8 n by 10 is equal to 8 multiply by n. N is 207 and divided by 10. So 165.6. Again, you have to go to the data and to check where 165.6 comes. So 167.6 comes in this class, 193. So no, 165.6. So 165.6 lies in is this class only, because 178 to 193 is in this class, but 166.5 lies in 1150 to 1200 class. So again the D8 class is 1150 to 1200. So now again, if we want to calculate this, so same is this. L is 1150 plus of A10 by 10 minus of cumulative frequency above it. So cumulative frequency above it 103 divided by the same class frequency, which is 74, and multiply by I. I is again 50. So 1192.297, that will be the value for D8, which says 80% is below it and 20% is above it. So in that way you can calculate anything. Now P35. Suppose we want to calculate P35. So P35 is 35% below it and 65% above it. So for that you have to calculate, because it is P. So it is N by 100 equal parts, and as it is 35, so it becomes 35 N by 100. So first we have to calculate 35 N by 100, which is 35 multiplied by N. N here is 207. N is total number of elements, which is 207, and divided by 100. So 72.45. So you have to check in the data where 72.45 comes. So 72.45 comes in this class. So your P35 class is 1100 to 1150. The same formula we have to apply here, which will be equal to 1100. L is the 1100 for this class. So 1100 plus 35 N by 100 is 72.45, minus of the cumulative frequency above it, which is 52, divided by the same class frequency, which is 51, and multiply by 50 class size. So 1120.04. So that will be the value of this median, like P35, which says 35% is below it and 65% is above it. So in that way, we can calculate anything, any value if you want to calculate in the same family, you can calculate it like P78, P32, P16, whatever it is in the same manner. So you can calculate this median, mode, no, sorry, mode, median, quartile, percentiles, or deciles. Fine. Now next is the mode. The last in the central tendency is for the calculations of the mode. So in the mode is simple for the discrete data. So suppose this will be the data. So this is the data for the discrete. Now if we want to calculate the mode of this. So mode, the definition of mode is the value which is repeated maximum number of times, and repetition is represented by F. Repetitions are represented by F in this. So what is the maximum F in this? So maximum F is this 20. So that become mode is 20. Fine. Suppose this will be the value is 21. So the maximum frequency of this data is 20. So that means 21 is the mode. So the value which is repeating maximum number of times. So this is the value which is repeating maximum number of times. So mode becomes your 21. ठीक, so in that way you can calculate. The mode is the simplest. You have to check only the frequency, which is the repetition of maximum number of times. So F is representing that same, that how much time this number is repeating. So 20 is the one which is repeating maximum number of times. So 20 is the repetitions for which element, that is 21. So 21 is your mode. Fine. Now, again, the mode for the continuous grouped data. So let's suppose this, I'm copying this data. I'm copying till midpoint. So I have, because there is no other way but to have a midpoint in the case of continuous grouped data. Without midpoint, we cannot do any question. So midpoint is required in that case. So if we have X, F, and M, we want to calculate the mode for this data. So we want to calculate the mode of this particular data. So now if we want to calculate the mode of this, so here again, you have to see the maximum frequency. Maximum frequency is this 74. So that from this we come to know that the modal class is 1150 to 1200. But from 1150 to 1200, which is the mode, that is yet to be known. But from this, we can come to know that 1150 to 1200 is the modal class which has the maximum frequency of 74. But what is the value of mode from 1150 to 1200? That is yet to be found. So for that reason, we will take mode formula. So mode is equal to L plus mode is equal to L plus F1 minus F naught F1 minus F naught divided by 2 F1 minus F naught minus F2 and multiply by I. So that becomes the formula for the mode in the case of continuous grouped data, where L is the lower limit of the class, F1 is the frequency of the same class, F0 is the frequency of the above class, and F2 will be the frequency of the below class. So as we have found that this will be my median, this will be my mode class. So 1150 to 1200, this is my mode class. So now L here is the lower limit of this class, which is 1150 plus of F1. F1 is the frequency of the same class, which is 74 minus frequency of the above class. F naught is above class, which is 51 divided by 2 into F1. So 2 into 74, F1 is 74 minus of 51 minus of F2 is the next class, which is 60, and multiply by I, which is 50. So 1164.19, that becomes the mode. So 1164.19 represents the value which is repeating maximum number of times in the data. So that becomes your mode. So in that way, you can calculate the mean, median, mode of any data of any nature you can find from this. So that is the way we can find the central tendency measures of mean, median, and mode. And I've already explained you what is the implication, that where you can calculate the mean, where you can calculate the mode, and where you can calculate the median. So each and every measure of central tendency has their own meaning, has their own implication. But the thing is, we have to judge that in which situation we have to apply which tool so that we can get the appropriate information. But by default, mean is the most appropriate way to take the central tendency, because it will take into consideration each and every value into its calculation. But mean and mode is not taking each and every bit. Mode only takes the maximum value which is repeating, and median is the value which is like divide the equal parts. But what is that lowest part and what is the higher part, it does not bother on that thing. So that's why we have to consider the case where we can get a more information from mean, or from where you can median, or from where you can get the from the mode also. So that will be your measures of central tendency, mean, median, and mode. So now your next is the, if we are taking the data descriptives, now next is for like the next measure. The first is like measures of central tendency that we have already discussed. Now next will be your measures of dispersion. So So next part comes your measures of dispersion. So measures of dispersion says that how our data is dispersed. Dispersed means variations present in the data. So that we have to represent in the measures of dispersion. Like I'm again taking the same example as I have discussed in the previous class also. Suppose the data will be like 333, sorry, 33333. One data set. Suppose this will be my data 33333. Another data will be like 1 2 3 4. So 1, 2, 3, 4, 5. So this will be my two data sets. Now we want to calculate the measures of like represent this data. So if we are calculating the measures of center density in this, what is the mean of this data? So if we calculate the mean of this data means sum of all the elements. So first of all we have to take the sum of the elements and then divide it by the number of elements. So the total of both these data comes out to be 15, and the number of elements also here is 5, and number of elements also here is 5. So 15 by 5, the both the numbers, the mean comes out to be 3. But with the angle of mean, we can say the two data are same. If we are calculating only the measures of central density, parallel, these two data sets have the same meaning. We are representing to our management that the data will be the same because the mean of the both the data comes out to be 3 only. But if actually the data is same, there is a difference between this data and this data. The mean value is both the data, the mean comes out to be same, but actually there is a difference between this data and this data. So what is that difference? That difference lies in the measures of dispersion. So in this data, we can say there will be no variations in the data. So every value is 3, every value is equal, so there will be no variation present in the data. But if we see actually this particular of 1, 2, 3, 4, 5, so you will self see the difference, like there is a dispersion. The value of 1 is also there and the value of 5 is also there. So there is a variations in the data, but in this particular first case, there will be no variation. The dispersion is 0. So that we want to calculate now. If we want to calculate the information in full terms, we have to make the both the things parallel, the measures of center density also and the dispersion also. So the dispersion will tell me the variations present in the data. More the variations, more the measures of dispersion. Lesser the variations, lesser will be the value of dispersion or so. So anything we, and it is a practical version, like in the form, if I'm talking of management terms, in the management finance is all about like returns and risk. So what is a risk? Risk is when you can see that what is the measure of a risk. If we want to measure the risk of something, how we can measure that risk? Risk is implication of how we can measure the risk. Risk can be implication for like how much the data is, to whom you are saying that is more risky. The risky thing is like which have more variations, like for example a patient health is, we are claiming that this patient health is very risky or very critical. When the doctor is claiming that risk, if the condition of that particular patient will be like too much variations, once a bp is like 90, at one moment it become 150, and another moment it becomes 170, so the doctor can claim that it has a more risky. But the other patient has a constant bp of maybe 95 or 90, so we can see that they have a less risk prone to health. So that variations will represent my risk level. So that is the practical version. If we are want to measure the risk of something, we want to check the variations present in the data, and that variation will tell me that measures of dispersion. So from that dispersion itself, we can come to know that what are the variations present in the data in R. So this measures of dispersion will tell if there will be a less variation or if there are more variation in the data. So for that, we want to calculate this measures of dispersion. So we have the measures, as in the case of measures of central tendency, we have the mean, median, and mode. In the case of like dispersion, we have four measures. The first one is called as the range. The next one is called as the mean deviation. So the range, mean deviation. Then we have a standard deviation, and the fourth one is your variance. So these are the four measures of the dispersion in which we can calculate our like measures of dispersion. Again, these four have their own implications, have their own meaning. But again, we have to see that which tool has to be applied. in which situation to get the maximum information. Fine. So the first of all, that is the range. Range is the least used method because it is not so effective. Because the range simply says we want to calculate the range of the data, which will be like highest minus lowest. So that will be the range. So that is the simplest form. The data, highest value in the data and the lowest value in the data, you have to subtract that. That will present the variation. And it is actually the variation. Highest data and the lowest data that will show the variation present in the data. So that is the simplest form of the measures of dispersion. It will tell the variations of the presence in the data itself. But what is the problem in the range? What is the problem in the range? Why it is least used? It shows the dispersion in the data, but it is the least used method and it has suffered with a major disadvantage. So, what is that major disadvantage? The major disadvantage is like it will only consider the extreme values in the data. It will not take into account each and every value. But for example, in this case, if we will take this example 1, 2, so if we'll take this 1, 2, 3, 4, 5, and we want to calculate the range of this. So range becomes highest minus lowest. So 5 minus 1, it is 4. So 4 is the range of this data. But if we are talking of this thing, 1, now what is the range? Range of this data is also 4. The range is also 4 for prime first and range is also 4 for the second. But again, if we are to see, there will be only range because of the extreme values. The range will not take into account the intermediate values, that what are the intermediate values are there in the data. So it will not take into account what is 2, 3, 4 or all three values. Let's suppose this value becomes, so if this value will change, then only the range will change. So if this value will change, then only the range will change. But if the medium value, if the medium values will get changed, there is no effect on the range because the range will take into account only two values in the data, highest and the lowest. So that is the major drawback of the calculation of the variations from the range because it will take into account its calculation only the extreme values of the data. It will not take into account the every value of the data. So that's why the range, we are hardly use the range as a measures of dispersion, but we are using the range in the case of finding the outliers. Outliers are some extreme values in the data. So if we want to find that outliers, we can use this range. For example, we have made one questionnaire and we are representing the data in the form of 1, 2, 3, 4, 5. On the scale of 5, we are asking the respondent to give the answers. So the every respondent has to give the answers from 1 to 5. So either 1, 2, 3, or 4 or 5. So I have collected my responses in the scale of 1, 2, 3, 4, 5. But by chance, when feeding the data into the data sheet, 5 is feeded as 50. So maybe 5 is treated as 50 by mistake. There is a number 5. The customer is highly satisfied, so we have made it 5. But maybe at the time of data entry into the system, 5 will be entered as 50. So maybe by error or maybe by chance that 5 is typed as 50 in the data. Now the problem is if we calculate the range of the data, the range of that comes out to be 49. 50 minus lowest is 1. So the range comes out to be 49. From that 49, we come to know that it is not possible by calculating the range coming is 49. So we can simply click that 49 cannot be the range because range can be like maximum value can be 5, minimum can be 1 because the scale is from 1 to 5. But our range comes out to be as 49, so there is some error in this. So we will spot that outlier present of 50 in the data. So we can find that outlier of 50 in the data and we can identify that and we can check that particular data value to see that where the outlier is. Which element is get like I don't have to check the complete sheet. I have to check only that column in which I don't have to check every element in detail that where is the typing error. I have to check only that column which the range comes out to be 49. Maybe I have 50 variables and maybe 500 respondents. So there is a metric sheet of 50 into 500. So I need not to check each and every 50 into 500 values. I need to check only that column of 200 respondents, maybe where my range comes out to be 49. So that is the like application of the range to find only the outliers present in the data. But otherwise, normally speaking, we are not applying the measures of dispersion through this range. So that is the first tool for measures of dispersion, like the range. Next comes the mean deviation. So mean deviation is now from mean deviation, this measure of dispersion will take each and every value into its. So each and every value will take into consideration that is the mean deviation. We will calculate like how we can make this mean deviation at all. So in this, the mean deviation, each and every value will be into its account. So let's suppose we'll take the same example for again the same individual discrete, grouped discrete, and continuous grouped. So for all the three types of the data, we have to calculate the mean deviation. So first we'll calculate for individual discrete. So individual discrete may be like the same 1, 2, 3, 4, 5. One second. Hello, audible.
Yes,
Yes,
sir. Yes,
sir.
sir.
So so that is mean deviation 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is the data from which we have to calculate the mean deviation. So mean deviation, the objective for calculating the deviation is we have to calculate the variation. So variation is how we can calculate the variation. The general idea on the variation is you have to remember this concept. You don't have to remember only the formula, but the background of the same, that how we can find that deviation. Deviation means you have to find the variation. Variation we can found it like by a difference a minus b, we can find the variation. So we want the variation of each and every value from a certain number. That is a reference. Reference is like, suppose I'm taking one example. I'm making one statement. Delhi is 200 kilometers. It means something or not? I'm making one statement like Delhi is 200 kilometers. It does not make any sense until and unless I'm defining the reference point. Until and unless I'm not defining the reference point of the data, I will not, the statement has no meaning. Like ambala is sorry, Delhi is 200 kilometers. Until and unless I'm not defining it that Delhi is 200 kilometers from Ambala, then only we can say that the reference is correct, the distance of 200 is correct. But otherwise, if I'm saying only the statement Delhi is 200 kilometers, so it does not make any sense. Somebody has to ask that Delhi is 200 kilometers from which place. So from is very important in that particular case. So that from has to be added in this. So that is the reference point. And again, the same, I'm making this logical relation with here is we want to calculate the variation of each and every value. That one, what is the variation present in the 1, 2, 3, 4, 5, and so on. But for that, we want some reference value from which we have to calculate the variation, from which we want to calculate our variations present. So from that reference value, we have to take the distances of each and every value from that reference value. So what is that reference value? Now the next question comes, what is that reference value? That reference value is none other than your measures of central tendency. So whatever the measures of central density, that is the central value of the data. Now we will calculate the variations of each and every element from that central value. And that measures of central density can be your mean, can be your mode, can be your median. But by default, if we are taking the mean deviation, it will be about mean only. But in case it can be about mode or it can be about median also. But again, if you want to calculate about median or about mode, it is specified written over there. You have to calculate the mean deviation about median or mode. But in case if it is simply written that you have to calculate the mean deviation, you have to calculate it about mean itself. Now the first requirement of this is you have to calculate the x mean, x bar. You have to calculate the value of x mean. So how we can calculate x mean? That is the sum of all the elements divided by the number of elements. So 55 divided by 10, that comes out to be 5.5. So that will be the mean value, sum of all the elements divided by the number of elements. So 55 is the total divided by the number of elements, that is 5. So 5.5 is your mean value. So now this is your x values. Now you have to calculate the variation. Now you have to calculate the variations present in the data. So for that we have to calculate x minus x mean values. That means you have to calculate the x minus x mean values becomes variations of each and every value from that 5.5. So that means each and every value, x is 1, x bar is 5.5 for each and every value. So that becomes is equal to 1 minus of this x average. So this has to be fixed. So we'll take the help in Excel, we can take the help of this. So this comes out to be minus 4.5. Otherwise, you have to subtract track 1 minus 5.5, 2 minus 5.5 and all. So if we'll drag this in the Excel, it becomes your, so this becomes minus 4.5, 3.5, minus 2.5, minus 1.5, minus 0.5, then 0.5, 1.5, 8 minus 5.5 is 2.5, 9 minus 5.5, 3.5, 10 minus 5.5 is 4.5. So this becomes your x minus x. Now these are the individual variations present in the data. The next task is to calculate the total variations. In this, we have calculated the individual variations. What are the individual variations present in the data? So this is like individual variation in the data, but our task is to calculate the overall variations. To calculate the overall variation in the data, so what we have to do, we have to add all these individual variations to get the total variation. Individual variations we have already calculated. Now, if we make the total of these individual variations, we'll get the total variation present in the data. So for that, it will make the simply the total of this. It becomes 0. But if it is actually 0, the next challenge comes over here. It will make the total of these all values of individual variations. It comes out to be 0. But if 0 signifies there is no variation present in the data. But actually, if there are variations, there is the 1 also present in the data, there is 10 also present in the data. So there should be a value of like variation. But my data says it is the value is 0. Zero values only comes when all values are like 3 each, 5 each. So then only we can say that there will be a zero dispersion in the data. But in our case, there is a value of dispersion, but our data says it's 0. So there is some problem in this. So what is that problem? The problem is like this negative dispersion value will cancel out with this positive. But variations is this negative also and positive also. For me the variation is 1 also is a variation and 10 also is a variation, 2 also is a variation, 9 is also a variation. So but this is like this variation will be get cancelled with this negative and positive get countered to each other, and that's why the answer becomes out to be 0. So for that reason what we have to do, we have to make our negative variations positive so that the negative and positive will not cancel each other, so that negative also to be added in the net variations part. So we have to find the measure how we can make a negative variations to the positive one, so that these variations will not cancel out each other. These variations must be added to the net answer. So we'll ask mathematics. So there is a problem like how we can convert our negative variations to positive. So then I'll go to mathematics and there we'll find the ways how we can convert a negative number to positive. So there the mathematics will tell me that there will be two ways to convert a negative number to positive. That is, one is the operations of modulus operation, and the another one is your this square operation. If we'll take the mod of the data, the negative number will convert into positive, or if you'll take the square of the data, then also the negative number becomes the positive. So there will be two ways to convert a negative number to positive, so mod and the square. If we use the conversion of negative to positive by modulus, then it is a mean deviation. If we make the square operation, then it will be a standard deviation. So that is the difference between the mean deviation and standard deviation. Mean deviation we are making it the modulus, and the positive we are making by the modulus, and standard deviation we are making it by square. So first we are taking the mean deviation. So in the mean deviation we have to calculate the modulus of this x minus, you can say modulus of x minus x bar, or mean you can say. We'll use the same word. So modulus of x minus x bar. So that become minus 4.5. We will take the mod of the same. It becomes 4.5, 3.5, 2, 2.5, 1.5, 0.5 plus, and then again this. These remain the same. Positive will remain the positive, negative will change into positive numbers. So positive numbers will remain positive and negative numbers will become positive itself by applying the mod operations. Then these are the individual variations all in positive now. Now if we have added all these, so if we make the addition of all this, it becomes the total variation present in the data. And now the value of mean deviation becomes, so what is the value of mean deviation, which will be equal to summation of, not making equal to, otherwise we'll take the formula, summation of modulus of x minus x mean. That means this number, summation of modulus of x minus x mean, so that is this data, and divided by and it has to be divided with the number of element, that is divided by n. So that becomes the formula for mean deviation. So sum of all the individual deviations divided by the n, that becomes your mean deviation. So here in this case, mean deviation comes out to be 25 divided by number of elements are 10. So it becomes 2.5. So the value of MD becomes 2.5. Clear? Now if we'll take each and every value as suppose equal. So we'll change this. We'll make this 3. So if we'll take this, what is the value of x mean? So 30 by 10 is 3. So this becomes 0. X minus x becomes all 0. So the sum is also 0. 0 by 10 is 0. So the mean deviation comes out to be 0 when all the values are equal. So logically also it's true, and through calculations also it is coming out to be true. So that becomes that mean of each and every value, if mean deviation of 0, because when every element is all same, then it becomes the mean deviation is equal to 0. Fine. So that case will be like the mean deviation in case of individual discrete data. Now comes to the standard deviation of the same individual discrete data. So we'll calculate in this way. Like first is the individual discrete data the mean deviation and the standard deviation. Now, if in this case we want to calculate the standard deviation of the same. So this is up to this the step remains the same. For x, this mean we have to calculate 5.5. Now x minus x mean, up to this step it is same, but only the difference is the method to make it positive. In the case of like mean deviation, we are taking the modulus. In case of standard deviation, we are making it with the square. So then it becomes then it becomes x minus x mean. So x minus x mean raised to the power 2. Raised to the power 2 means square of this. Then becomes, it is again positive. So if we make the square of this, so it equal to this raised to the power 2. So this becomes your x minus x mean raised to the power 2. And if we make it for all, so these becomes the values of x minus x mean raised to the power 2. Every value is positive now. So again, we have to take the sum of all these values. So if we take the summation of this, 82.5 is there. So the SD value comes as, again, the sum of x minus x mean. X minus x mean का square divided by n. Clear? But there is one variation in this. We have made the square of our own. The question does not demand the square. We have made this square because to make the variation into positive. So we have to nullify that. So again, we have to make the under root of the complete. So whatever the answers come, we have to make the under root of the same. So raised to the power 1 by 2. Under root of the same answer. So that means the answer becomes sum of this x minus x bar square. So which is 82.5 divided by 10. 10 is the number of elements and the under root of the same. And if we have to take the under root of the same, which will raise to the power zero point 0.5, so 2.87 value comes out to be for the standard deviation for this. So if we'll check the standard deviation for this data, so it comes out to be 2.87. It becomes like the formula becomes summation of x minus x bar whole square divided by n under the root. So if we'll check about the formula for standard deviation, so is equal to summation of x minus x bar whole square divided by n and the complete under root. So that will be the formula for like calculations of the standard deviation. Now the last here in the measure of dispersion is the variance. Variance is none other than the square of SD. If it does not make the under root of the answer at the last of the SD, it becomes the variance. So SD and variance is more or less the same thing, but the only difference comes in the part is like SD is the under root part, and when we are squaring the SD, we get the variance. So that is the only difference between the standard deviation and the variance. So again, if we are talking of the best tool for the measures of dispersion is standard deviation. 90% of the time we are measuring the standard deviation measures of dispersion with the standard deviation value. And the standard deviation value also represented by the like letter sigma. So it is represented by the letter sigma, and I'll show the symbol for sigma. So sigma is like this. So this is the sigma value, and the standard deviation will be represented by this sigma value. So sigma is equal to under root of x minus x mean square divided by n ka under the root. So that will be the method to calculate the measures of dispersion, like from range, mean deviation, standard deviation, and variance for individual discrete data. Now, the same thing we want to calculate for grouped discrete. So let's check out with the grouped discrete data. So group discrete. So this is suppose your grouped discrete data. Now we want to calculate the measures of dispersion for all those. So let's suppose this will be the data x and f, and we want to calculate the mean deviation, estimation, range, variance of all for this type of data. Now the range. The first is range. The range itself says the minimum and the highest value. So if we talk of this range, minimum does not take of the f. So range becomes 21 minus 5, that is the 16. So that is the simplest way to calculate the range, like smallest value in the data and highest value in the data. 5 is the minimum, 21 is the highest. So you can simply subtract that and you can get a value like 16, which is the range of the data. Now comes to mean deviation of this type of data. So for the mean deviation, again we have to calculate the mean, because about mean we have to calculate. So first thing we have to calculate, that is about the mean of this data. So if we'll calculate the mean of this data, then it will be, so mean is, first you have to calculate fx values, because summation fx divided by summation f, that will be your mean. So that's why we have done measures of central tendency prior to the measure of dispersion. You cannot do dispersion after, like before measures of central tendency, because you need measures of central tendency in the calculation of measure of dispersion. So again we have to calculate the mean. So mean can be calculated by summation fx divided by summation f. So which will be equal to f into x. So we will calculate f into x. Individual fx we want to calculate. So individual fx. Then sum of all fx becomes summation of fx. So summation of fx becomes this. And now if we calculate the mean x bar, it will take the value of x bar. So x bar is equal to summation of fx divided by summation of f. So we have to make first summation of f also. So summation of f we are taking it, so it will be, so 39. So the mean value comes out to be 686 divided by 39. So that becomes your x mean. Now we have to calculate x minus x bar. So x minus x mean you have to calculate. So in the same way, we have to calculate x minus x mean, which will be equal to 5 minus this mean, and this has to be the same for all. So this is your x minus x bar, and you have to each and every value you have to subtract this. So this becomes your individual x minus x bar. Now you have to make it as square also in the same manner as we have did in the previous. So at one second.
Excuse me, sir. Your mic is off.
Sorry. So we have calculated like x minus x mean ka square, then f into x minus x mean ka square ka sum. So we have to multiply this with f, because this variation is not once, it is two times, it is four times, it is again two times, and so we can get it like 317230, and this is the total variations. So 831 becomes as the total variations, and divided by the number of elements, that is sigma f. So here we, and this is, and then you have to take the under root of the same. So the number of elements is summation f, not n. So that's why we have to raise to the power by 0.5. So this 4.61 becomes the variations of this data. So if we want to calculate the standard deviation of this data, so this comes out to be 4.617, which shows the standard deviation value of this data is like 4.617. Fine. And if we want to calculate the variance, so variance becomes, the variance is the square of the SD. So this raised to the power 2. So raised to the power 2, that becomes 21.318, that becomes your variance. In the same way, if we want to calculate for mean deviation, so in spite of making it square, you have to make it like mod. So if we'll take the mod of this, so mod of this big function becomes x minus x mean. So it becomes, for these all values, it becomes positive. So if we'll take the mod function, we have to apply the modulus function. So if we'll take the modulus, no, modulus is not in Excel, is like this. You can simply make it like into -1. For all these values, you can simply multiply with -1 to make it a positive. So -1 multiply by this. So this becomes your positive value for the same. Up to this, we have to multiply with -1, and these two will be like the same. Positive values will remain the same. So these becomes your modulus values, that is x minus x mean mod. Then this will be multiplied with f. So f into modulus of this. So now you have to multiply this value with the f. So f multiply by these individual mod values. So this comes out to be your f into x minus x bar mod. So this will be your values. We have to sum all these values. And then the formula for MD becomes summation of f x minus x bar divided by average, divided by the summation of f, which will be equal to summation of this divided by summation of f. So this becomes your MD value. So mean deviation value comes out to be 3.78698. So that becomes the like for the mean deviation. So in this way, we can calculate the mean deviation, standard deviation, variance of the discrete grouped data. Now for the continuous grouped data, the only difference is like the calculation of midpoint. Once you have calculated the midpoint, that m will be replaced with this x, rest of the question will remain the same. So again, fm you have to calculate, then m minus m mean square and all that. So whatever the x in the question will be replaced with the m now, and you have to do after calculations of the midpoint. So the same question as the case of a discrete grouped data, you can calculate it for continuous grouped data. So it will be this same part. As we have did in that, you can do the same part in this only. So that will be our parallel option you can do it with. So that is the way we can calculate this all for continuous grouped data also. Fine. So this covers your measures of dispersion also. But with the one thing is like if we want to calculate the standard deviation, only standard deviation I'm talking of. If we want to calculate the standard deviation about mean, if it is about median or mode, the only difference comes in. Let's suppose we have calculated is for about mean. If we want to calculate about median, in spite of calculating the mean here, we have to calculate the median here. So we'll calculate the median, then becomes that value will be replaced with x minus x mean. Here the mean and median comes out to be same. 5.5 is also the median. But in case if we want to calculate with the median, the only thing is we have to first calculate the median, not mean, and that value is x bar. Now you have to subtract x minus x bar in that way. So the only difference comes in the calculations of that median, and then accordingly the further process will remain the same. But in case if we want to calculate the SD about mean, there is no need to having the two process. It is a question like two-way process. First step is to calculate the mean. The next step is to calculate the standard deviation. In two steps we have calculated. But in the other way, the example which we are doing right now, in that particular example, we can take the value of standard deviation at one step only. We need not to calculate the mean in a separate way. But this method is only applied when it is a standard deviation and also it is about mean. If it is standard deviation about mode or about median, we have to do in the way in which we have already done. But in case if it is asking like about median, sorry, about mean and standard deviation, then we can use this method also which we are using now. The advantage of this method, answer will remain the same, but the advantage is we don't need to calculate the mean as a separate. In the formula itself, the mean is calculated internally only. So let's suppose do that thing. So this is the data for individual discrete, and for we're doing it for group discrete only. So because individual discrete does not have its small formula only, so we can do it with the group discrete one. So this is the data. We want to calculate the standard deviation. So standard deviation, the formula says sigma is equal to the formula for one step formula. The one step formula for sigma is equal to summation of fx square summation of fx square summation of sorry or we will do this in the next class. So there's a shortage of time now. You cannot complete this in the next 5 minutes only. So we will doing it will be in the next class. So the only thing which is left in this measures of dispersion is like a one step formula to calculate the mean. Fine, but otherwise the answer will remain the same whether you are doing it as a two-step process or a one-step process. But the thing is, in the advantage of this method that we have to do to the next class is we can do it in a one step. We need not to do have a two steps in this. That is the only advantage of using this method. Fine. So with that, your measures of dispersion and central density is over. And 1 second, I'm stopping with the recording.